Within this video today we are discussing about the photoelectric effect within the quantum mechanics topic. Okay, so photoelectric effect. So what is mean by photoelectric effect? Okay, so this is a particle nature only. Okay, so photoelectric effect is the particle nature of a matter. Okay, so photoelectric effect. So what is mean by photoelectric effect? And this is a very well known topic, I think so. Okay, so for example, if I took a material, okay, so or a metal, okay, so if the light is incident on this material or metal, okay, simply we are consider one metal or a material, so the light is incident on this material. Okay, whenever the light is incident on this material, what happened here? Within this material we have the number of atoms. Okay, so within those atoms, what happened? The electrons are existed. Okay, so that's why whenever the light is incident on this metal surface, what happened? The electrons which are present within this material, those are get excited and they will be liberated from this photosensitive metal. Okay, so ejection of this electron or liberation of electron from the photosensitive metal whenever the light is incident. So this process or this effect is known as a photoelectric effect. Simply whenever the light fall on this material or metal, what happens? The electrons which are present within this material, they will get the energy from the incident light. So then what happens? They will be liberated from this photosensitive metal. Then this effect is known as a photoelectric effect. And the liberated electrons which are liberated from the photosensitive metal, those electrons are known as a photoelectrons. Why we are called as a photoelectrons? Why? Because these electrons are liberated from the photon. Light is the form of photon, so that's why these electrons are known as a photoelectrons. Okay, so simply photoelectric effect is nothing but here we are consider one photosensitive metal or the metal. Okay, so whenever the light, okay, so this is the light we have. Okay, so light is in the form of photon, so that's when the here whenever the light, okay, so light incident on this photosensitive metal. Okay, photosensitive metal, whenever the light is incident on this photosensitive metal, what happen? The electrons which are lies within this material, so those are get excited and liberated from are ejected from this photosensitive metal. So these electrons are known as a photoelectrons. These electrons are known as photoelectrons. Why we are called as photoelectrons? Why? Because these electrons are liberated from the photon. Okay, so why? Because the light is in the form of which one? Photon. So the electrons are liberated from the photon, are liberated by the photons, so that's when we can call it as a photoelectrons. Okay, so simply then this process is known as a photoelectric effect. Whenever the light is incident on photosensitive metal, the electrons which are present within this photosensitive metal, those are absorbing the energy and excited. So due to the excitation, they will be liberated or they will be ejected from this photosensitive metal. Then those electrons are known as a photoelectrons. Okay, and the process is known as a photoelectric effect. Okay, so that is the concept of photoelectric effect. Okay, so then this photoelectric effect, okay, so this photoelectric effect depends on the three things. So what are those three things? Okay, majorly depends on the three things. So the first one is the intensity of the light. Okay, so intensity of the light. Second one, it will be depends on the frequency of the light. Intensity as well as the frequency of the light. Okay, so the last one is that is a photosensitive metal. It will be depends on the photosensitive metal. Okay, so the photoelectric effect process will be depends on the three things. Those are nothing but intensity of the light, frequency of the light, as well as a photosensitive metal. So then how this photoelectric effect depends on the intensity of the light. Okay, so how it will be depends. For example, this is a photosensitive metal. The electron, so the light is incident, okay, and the electrons are ejected. Yes or no? The electrons are ejected. Okay, so whenever the intensity of the light increases, that means this incident light increases, intensity increases, then what happen? The number of ejection electrons also increases. Okay, number of ejected electrons also increases. That means if we are increasing the intensity, then the number of electrons also increases. Okay, so then what is mean by intensity here? Intensity is nothing but supplied energy. For example, here if we are supplying the 100 watts of intensity, okay, so then for example here 100 number of electrons are ejected. Okay, so if you are supplying the 200 watts of energy or 200 watts of intensity, then 200 electrons are produced. Okay, so if you are producing 500 watts of energy, okay, so then 500 electrons are ejected. That means both are proportional with each other. Okay, so the intensity of the light and the ejected electrons both are proportional with each other. Okay, so but up to a certain limit only. Okay, up to a certain limit only, where the limit that is we can call it as a saturation current. Okay, we'll discuss in the later classes. Okay, so intensity of the light. Okay, so while we are increasing the intensity of the light, okay, so then what happens? The number of ejected electrons also increases. Simply, and the number of electrons also increases. Okay, now comes towards the frequency. Okay, so if we are increasing the frequency of the light, okay, incident frequency of the light, then what happened to the photoelectric effect? Again the same thing here. Again we are consider photosensitive metal. Here the light is incident on the photosensitive metal. Okay, so then what happened? The electrons are ejected. Okay, so if we are increasing or decreasing the frequency, okay, if you are increasing or decreasing the frequency of the light, then the electrons, ejected electrons also increases or decreases. That means if we are increasing the frequency, here the number of electrons, ejected electrons also increases. If you are decreasing the frequency, then the number of ejected electrons also decreases. That means again the frequency of the light and the ejected electron both are proportional to each other. If you are increasing the frequency, then the ejected electrons increases. If you are decreasing the frequency, then the ejected electrons also decreases. So what is mean by frequency here, sir? So frequency is nothing but it is in the form of colors. Okay, so for example, if you are producing the if you are incident the red color, then some amount of the electrons are ejected. If you are producing, if you are incident the yellow color light on the photosensitive metal, then somewhat of electrons are ejected. If you are producing, if you are applying a violet color, then somewhat of electrons are ejected. That means that the frequency will depends on the color of the light. Okay, so if you are increasing the frequency, why? Because each color will consisting of different frequencies. Okay, so that's when if you are increasing the frequency of the light, what happen? The ejected electrons also increases. If you are decreasing the frequency, the ejected electrons also decreases. So that comes towards the next one, photosensitive metal. Okay, photosensitive metal. Okay, so if we having the uh, a soft photosensitive metal, then major number of large number of electrons are ejected from the photosensitive metal while the light is incident on it. Okay, so if you are having the harder photosensitive metal, a small amount of electrons are ejected from the photosensitive metal. Okay, so that's when we can say that the photoelectric effect always based on the intensity as well as the frequency of the light, and it will also depends on the photosensitive metal. Okay, so that is about the photoelectric effect concept. Okay, so then after, so Einstein photo energy relation. Okay, Einstein photo energy relation. So what is the Einstein photo energy relation? Photo energy relation. So what is the Einstein photo energy relation here? So the Einstein photo energy relation is nothing but, so for that one again we are consider one photosensitive metal. Okay, so sorry. Okay, so here I am consider one glass tube. Okay, so and which is having the one hole. Okay, so which is used to incident the light. Okay, so here I have the one electrode, and here also again I have the one more electrode. So both are connected to the battery. Okay, so here it is a negative one and here it is a positive one. Okay, okay, so here the light, a suitable light is incident on this one. So this is a anode. Okay, and this is a cathode. Okay, so here we have the negative and here we have the positive. Okay, so this is the experimental setup of photoelectric effect. So then, so here we have the potential difference. Okay, so and we are connecting the one ammeter. Okay, so why we are connecting the ammeter here, so we discuss later. Okay, so once you observe here, for example, this is a photosensitive metal. Okay, so the negative terminal of the battery is connected to this anode and the positive terminal of the battery is connected to the cathode. Okay, so then what happened, whenever the light is incident on this anode or photosensitive metal, what happened, the electrons are ejected. Okay, here the electrons are ejected. So and these electrons will consisting of which charge, those are consisting of a negative charge. Okay, always the negative charges are attracted by this positive charge or a cathode. So that's why all these liberated electrons are moving towards this cathode. Okay, simply whenever the light is incident on this anode or this photosensitive metal, the electrons are ejected due to the photoelectric effect process. Okay, so these ejected electrons are tends to move towards this cathode. Why? Because the cathode will attract the negative charge carriers. Why? Because the cathode will consisting of positive charge. Okay, so the positive charge as well as the negative charge both are attracted with each other. So that's why these liberated electrons always tends to move towards which one, this cathode or positive charge. Okay, so whenever the charge carriers are in motion, whenever the charge carriers are in motion, those are nothing but electrons are in motion, what happened here, the rate of flow of charges, okay, rate of flow of charges always produce a which one, current. It will produce a current. So that's why whenever the electrons are in motion, okay, whenever the electrons are in motion within this glass tube, what happened, it will generate certain amount of current. It will generate certain amount of current. This current is known as a photocurrent. We can know it as a photocurrent. Why we are call it as a photocurrent? Why? Because this current is generated by the incident photons or incident light. So that's why we can call it as photocurrent. Okay, so photocurrent. Okay, so then after, okay, so that process is known as a photoelectric effect. Then after, here we are changing the polarity. Okay, we are changing the polarity here. Okay, so that is nothing but in before case we are taking here negative and here we are taking the positive. Okay, so but we are taking the positive here and here we are taking, just we are changing the polarity of the battery. Okay, so while we are changing the polarity of the battery, so while we are increasing the negative potential, okay, while we are increasing the negative potential, this positive will be converted as a negative and this negative will be converted as a positive. Just we are changing the polarities, then what happened here, this terminal will be converted as a negative and this terminal will be converted as a positive. Again the light is incident on this photosensitive metal. Okay, so then what happened, the electrons are ejected, but once you observe here, the ejected electrons will consisting of which charge, negative charge. Again once you observe, the cathode will consisting of which charge, negative charge. Here we have the negative charge and here also we have the negative charge. Both are repulsed with each other. In before case, both are attracted with each other. But now both are repulsed with each other. So whenever both are repulsed with each other, what happens? This electron movement will be stops here only. Okay, they are not moving towards the cathode. Again, we are increasing the negative polarity here. Okay, so while we are increasing the negative polarity here, what happened, so at particular negative voltage or negative potential, what happened, the liberation of photoelectrons, okay, the liberation of photoelectrons will be stopped here. Okay, so that means the photoelectric effect process also stopped here at particular voltage. So then that voltage is known as a stopping voltage. We can know it as a stopping voltage or a stopping potential. Okay, at which potential the ejection of electron from the photosensitive metal will be stopped, then that potential is known as a stopping potential. At which potential the electrons, ejected electrons will be stopped, then that potential is known as a stopping potential. Okay, so this is the concept of which one, photoelectric effect. Okay, so and the next one, we have the some of the topics, okay, subtopics for this photoelectric effect. So what is that one here? First one is a threshold frequency. So what is mean by threshold frequency? What is the threshold frequency? Here we already know that the frequency of the light is always represented by nu. Okay, so the threshold frequency of the light is always represented by nu naught. It will be represented by nu naught or nu dash also. Okay, so whatever it may be, nu dash or nu naught. Okay, so then what is mean by threshold frequency here? Okay, so frequency is nothing but we already discussed that is the color of the light. Okay, so our the number of cycles per unit time within the oscillation. Okay, so threshold frequency. Okay, so for example, this incident light will consisting of a new frequency. Okay, so then what is mean by this nu naught or nu dash frequency? Here nu dash, that is the threshold frequency, is nothing but the minimum amount of frequency of the light. Okay, the minimum amount of the frequency of the light, so which is used to liberate the electron, from the photosensitive metal. That means if we having the nu not much of energy, so nu not much of frequency, okay, for this incident light, then only the electrons are ejected. Okay, so that's only we can say that the minimum amount of the frequency which is used to liberate the electron from the photosensitive metal, so then that frequency is known as a threshold frequency. So comes towards the second one, there is a work function. It will be represented by W naught. Okay, it will be represented by W naught. So what is mean by W naught here? In before case, within the threshold frequency, what happened? The minimum amount of frequency of the light which is used to liberate the electron, so that frequency is known as threshold frequency. Now the minimum amount of energy is in the form of intensity. Okay, so the minimum amount of intensity or minimum amount of energy which is used to liberate the electron from the photosensitive metal, then that energy is known as a work function of the photoelectric effect. The minimum amount of energy which is used to liberate the electron from the photosensitive metal, then that energy is known as a work function W naught. Okay, so that is about the threshold frequency as well as a work function here. Okay, so that is about the photoelectric effect concept. But here we want to derive the equation for the photoelectric effect. Okay, so how we derive the equation for the photoelectric effect? Okay, so for example, here we are again take the one photosensitive metal. The light is incident on this photosensitive metal, which is having the free energy of h nu. Okay, so h nu much, that is the photon energy. Okay, h nu much of energy will be incident on this photosensitive metal. Then the electrons which are present within this photosensitive metal, those are excited and liberated from the photosensitive metal. Okay, so then how much of energy supplied or how much of energy will be absorbed by this electron, and how they are liberated or how they are ejected from this photosensitive metal. Once you observe here, how much of energy we are supplying here for the this photosensitive metal is equals to h nu much of energy we are supplying to the first photosensitive metal. Okay, so for example, an electron will absorbing certain amount of energy from this from this incident photon. Okay, so then how much of energy? Absorbed energy, for example, absorbed energy or a threshold energy, that is a h nu naught. Okay, so this much of we are supplying to the photosensitive metal, this much of energy it will be absorbed. For example, one electron will be absorbed. Okay, so then how much of remaining energy we have for the photon? Okay, so the remaining energy, okay, remaining energy of the photon, photon E is equals to remaining energy of the photon E is equals to how much? The total energy minus absorbed energy. Then we'll get the remaining energy. How much the total energy? H nu. How much the energy absorbed by the this electrons present within the photosensitive metal? How much absorbed? H nu naught much of energy will be absorbed by the electrons which are present within the photosensitive metal. Then the remaining energy E is equals to h nu. E is equals to, here we are take the common h nu minus nu naught. Okay, so once you observe here, whenever the light or photon incident on this photosensitive metal, the electron will absorbing somewhat of energy, that is the h nu naught. So the remaining energy of the photon E. Okay, so how the remaining energy of this photon will be useful to this electron? So that remaining energy of the photon is useful to give the kinetic energy again to the same electron, then only it will be liberated from the photosensitive metal. So whenever the electron will be absorbing this h nu much of energy, h nu not much of energy, it will be just excited from the photosensitive metal. Whenever the remaining energy of this electron remaining energy of the photon will be supplied, okay, to the same electron, then it will be liberated and or it will be ejected from the photosensitive metal. So that's when the ejected electron will consisting of a kinetic energy. So that's when the remaining energy in the form of a kinetic energy of mv square, h into nu minus nu naught. Okay, so that is the relation of the, or that is the equation for the photoelectric effect of mv square is equals to h of nu minus nu naught. Okay, so that is about the equation for the photoelectric effect. Then after of mv square, for example here h nu is equals to h nu naught. Okay, so the incident photon energy only used to excite the electron, for example. Okay, it doesn't having the any kinetic energy. Okay, so then what happened, the kinetic energy is equals to 0, then h nu minus nu naught equals to 0, then h can be taken the left hand side, then nu minus nu naught is equals to 0, then we can write as nu naught can be taken the right hand side, then nu is equals to nu naught, or nu is always greater than or equals to nu naught. This is the condition for the photoelectric effect. Okay, so nu is nothing but incident frequency of the light. Okay, nu naught is nothing but absorbed frequency of the light by the electron. Okay, so from this equation, or from this condition, we can say that the incident light frequency always greater than or equals to the, which one, the absorbed frequency or threshold frequency. Okay, the incident frequency is always must be greater than the threshold frequency. Okay, so this is the equation for the photoelectric effect, and this is the condition for the photoelectric effect. Okay, so this is about the photoelectric effect. We'll meet in the next session. Thank you.